We're democratizing financial access for everyone. And over the past few weeks, our team has been focused on building an MVP showing the basic core elements of XOR. So I'm going to give you guys a quick demo of that today. So let's go ahead into the platform itself. So first we'll actually log out and show the login process. So that's done using Uport at the moment. But what's great about XOR is any element of the entire platform is actually programmable. So as you'll see here, when we get into the XOR platform itself, there's various markets. So there's various loan markets. So of course, you would have ones that were focused on requests and offers, some that might be in a lending period, some that might be in settlement where, of course, the lenders would be repaying a specific loan. And lastly, of course, the collection where the lenders actually collect the money back from the borrowers. So we're going to go ahead and create a market here. And as you'll see, of course, for the MVP, the request period is in minutes. Usually the request period would be in days, but of course in order to test this effectively, we have this in minutes for now. And you'll see there's a request period, loan period, settlement period, risk constant. Now what the risk constant is it's the average risk multiplier within a specific market, and it is used to determine, along with the trust score of a specific user, how much interest they're required to pay on a specific loan. The other element we, of course, have is the trust contract address. Now, this is very crucial to the core elements of XOR because it's the programmability element. And what it allows is it allows for people on the platform to actually program specific elements and then create markets that actually use that. So, for example, if I developed a new way of calculating a trust score or a new identity system, I would be able to program that, deploy that to the blockchain, and then actually use that within a specific market. In the future, people will be able to actually vote on proposals of different identity systems or trust protocols, any programmable element of XOR, in order for markets to evolve over time. So today we have a trust contract address that I've deployed. We've got this. We look real quick. We've got our example market trust contract that's actually been deployed to the testnet here, and it includes an interface for interfacing with the original contract, and it has a get trust score get trust score function here that actually returns the trust score of a specific user based on the number of repayments and defaults that they've done within a specific market. So we're going to go ahead and we're going to grab the contract address. We'll add it here. We will put a request period of 2 minutes, loan period of 2 minutes, settlement period of 2 minutes, and a risk constant, we'll just say 3 for now. So let's go ahead and create this market. Let's make sure MetaMask is working properly. Let me just log in. Perfect. All right, so I'll go back to this account. We're just going to reset this real quick. Do that again. There we go, 2, 2, 2, 3, and the contract address is right here. Fantastic. And then MetaMask pops up, and we'll submit that. And blockchain is just loading there. So there we go. So the market was just created. So we can go into here, and you can see that the request period has a minute, and 44 seconds left. We can go ahead and offer a loan. So they say offer a loan for 10 Ethereum, and we'll submit that to the platform. And then we're actually going to change accounts, and we're going to go over to a borrower account, and we are going to actually borrow from this market. So you can see the amount of offered was updated. We're going to request a loan for, say, 5 Ethereum, and we'll submit that. And that should be added shortly. And we'll just let that update. There we go. So now you can see here for the lender, the amount offered was 10 Ethereum. And the amount that they're actually lending within the market is 5 because only 5 Ethereum has actually been requested. And of course, the percentage of the market is 100%. We're going to do one more borrower within this market, and then we'll be good to go. So let's update here, and we'll do another request, say for maybe 2 Ethereum this time. Let's request that. And as you can see, the request period is almost finished within this specific market. And it's just loading, so we're just going to double check that. Perfect. So that has been updated. We've got 16 seconds left in the request period. And then after that point, we'll be able to actually withdraw the money. So if you're curious on how this is actually done in terms of updating the contract itself, basically what happens is within a market, you're able to set who the contract owner is, and then or for whoever like deploys it, and then they would be able to essentially decide which contract they're interfacing with, and then of course use that for implementing that into XOR. So we'll just let that load, and you'll see that another market's created, and you'll see that the other market will actually be put into the lending period now. Fantastic. So now as the borrowers, we can go to the dashboard, and we can go ahead and withdraw the amount that was requested. We'll just submit that. And we'll see here that we actually got the amount requested. And then we'll go ahead and go to the other account. And we'll go to the dashboard as well, and we'll withdraw. So amount available 5. So we'll request that we'll withdraw that 5 Ethereum. And as you can see, the blockchain is just loading. And we should be able to see the amount withdrawn was 5 Ethereum. Amount withdrawn for the borrower number 1 was 2 Ethereum. So both amounts have been withdrawn from the market. So usually, you'd have a loan that's maybe, say like a month or, 3 weeks. And then during the loan period, they would be able to use that money. And then after this, in 18 seconds, the market will actually go into the settlement period, and borrowers will be required to pay back that specific loan with the amount of interest. And of course, that interest is calculated using the trust score, which is completely programmable. So now we'll update. So let's just go ahead and create another market while we're at it. Okay. Just add a few more markets into the mix. And now we can see that the market's now in the settlement period. So now they're required to repay the amount that they've borrowed, and of course this is going to be 5.75 with an interest rate of 15% within the market. And since there's no actual credit history for the specific user, of course the interest rate is going to be a fair bit higher. And we're going to go ahead and settle that as well for the other borrower. And so they borrowed 2 Ethereum, and the repayment is 2.3. So we're just going to submit that. Great. So if we look at the settlement, we can see that the amount repaid was now set into the market. And then in the next period, the lender will be able to collect that amount. Now, you might be wondering, how do you prevent defaults from happening within a specific market? So there are going to be certain penalties put into place. Well, number one, certain markets will have margin requirements. So, say a 20% margin requirement that will be put into place in the market. In the case of the default, that collateral will be taken. As well as the concept of losing anonymity within a market. So, for example, just like in a real market, lenders and borrowers would know each other, and so in this case, borrowers actually have anonymity. And one of the elements that can be taken away in the case of a default is their anonymity, in order to take legal action towards that. And so. That's one of the elements that can be used to stop defaults from actually happening. So now we should be going into the collection period, and lenders will be able to actually collect the Ethereum that they originally lent out. So we're just going to switch to the lender account, and we're going to go ahead into the dashboard, and you can see there's actually some excess here. So we're going to collect that 8.05 Ethereum. So we're right now at 96. And let's go ahead and check that. Here we go, and that was transferred successfully. And then, of course, within the market also, there was some excess. 10 Ethereum was offered and only 7 was used. So we can transfer that excess as well, and we'll get that 3 Ethereum back, which we could have actually done right during the loan period as well. We're just getting around to that. There we go. So we've received our 3 Ethereum as well. So that shows like the entire process from beginning to end for specific lenders and borrowers. Of course, this just shows a quick MVP of programmability within the trust score, and we can actually go and look at the specific borrowers and lenders. We can see that within the market. You can see that each one has like a specific trust score associated with it, and that trust score was dynamically programmed into the XOR protocol. So essentially, each element within the protocol will be programmable, from identity to social staking to risk mitigation, interest rate, trust score, etc., which makes the protocol really strong. And also, the other element that's very cool is that at the end of each lending period, the lenders and borrowers will be able to vote on which elements they want changed within the market. So if the trust score wasn't calculated in a way that made sense within the market, or people felt wasn't fair, then they'll be able to vote for improvements to that over time, allowing the markets to essentially evolve. So if you guys have any questions about XOR, feel free to reach out in the comment section below. Also, be sure to read our white paper, which is on the website here. And definitely check out our GitHub, github.com/XOR protocol. We have some XOR external contract examples, as well as the XOR core, which was in the demo today. And thank you guys very much for listening.